Let S be the set of all positive rational numbers R, such that when the two numbers R and 55R are written as fractions in lowest terms, the sum of the numerator and denominator of one fraction is the same as the sum of the numerator and denominator of the other fraction. The sum of all the elements of S can be expressed in the form P over Q, where P and Q are relatively prime positive integers. Find P plus Q. So we're going to look at R and 55R. So for values of R, we want to consider values for this whose denominators divide 55. Because when if the denominator is just 1, this 55R, the sum of the numerator and denominator will always be bigger than R. So we want to look at values, where denominator divides 55. Prime factorization of 55 is 5 times 11. So we'll consider values for R that have denominators that are multiples of 5 and multiples of 11. So starting with denominators that are multiples of 5, let's look at, for example, see if we can see any patterns. So 1/5, if R is equal to 1/5. Sum here is going to be 1 plus 5 is 6. And if we do 1/5 times 55, that will give us, it's 5 times 11 over 5. The 5's cancel. This is 11 over 1. So the sum here is 11 plus 1, which is 12. So these sums are not equal. Looking at what's happening in this, when we multiply this by 1/5, so R is 1/5, and we multiply this by 55, it changes to 11 over 1. So what's happening here is denominator is decreasing by 4, and numerator is increasing by 10. Let's see what happens when starting with 1 over 10. So 1 plus 10 is 11, and if we do 1 over 10 times 55, again, that's 5 times 11 over 5 times 2. So these cancel, and we get 11 over 2. So sum here is 11 plus 2, which is 13. So again, not quite there. But looking at what happens when we transition from 1 over 10 to 11 over 2, this is going up by 10 like it did here. And this is decreasing by 8, which is different from what happened here. Basically, in order for these to be the same, sum to the same value, we need the numerator to increase the same amount as the denominator. We can make a little table here. So looking at multiples of 10, and then the numerator values. Basically, whenever we increase the numerator, and you can try this, the numerator is, when we increase it by 1, the amount that we're adding to this numerator is going to increase by 10. So when the numerator is 2, the difference between 55R, the numerator of 55R and R is going to be 20. And same thing here. And looking at the pattern with the denominator, so here the numerator increases and the denominator decreases, and that's going to be in multiples of 4. 4, 8, 12, 16. And the denominator values that accompany this are going to be in multiples of 5. So looking at when the first time these match, so when the numerator increases by 20 and the denominator decreases by 20, the numerator value is going to be 2, and the denominator value is going to be 25. So this fraction, 2 over 25, it's true that we can see, so 2 over 25, this sum is 2 plus 25 is 27. Multiply this by 55, and this comes out to 22 over 5, which is 27. So same sum. We continue this pattern here. So when this is going to be, we'll have the match with 40. That's going to be 4 over 50. But that's equal to 2 over 25. And so it's clear that when the denominator is a multiple of 5, then the only value that works for r is 2 over 25. This pattern is going to continue. It's going to be then 6 over 75, 8 over 100. It's the same fraction. So in this case, we can have r equal to 2 over 25. So the next case we'll look at, and we're going to apply the same thinking, is when the denominator is a multiple of 11. So looking at 1 over 11, 1 plus 11 is 12. 1 over 11, 1 over 11 times 55 is going to be 11 times 5 over 11. We get 5 over 1. So here, 5 plus 1, 6. Sum is not the same. But what's happening here is 1 over 11, when we multiply by 55, is becoming 5 over 1. So here it flips. This is decreasing by 10. This is increasing by 4. So the same table that we're looking at so here, the numerator increases in multiples of 4. So when the numerator is 1, it'll increase by a multiple of 4. When it's 2, increase by 8, 12, and so on, all the way to, and the denominator is decreasing by multiples of 10. So denominator values, these are 11, 22, because they're multiples of 11, 33, 44, and the multiples of 10, 10, 20, 30, 40. And so here we see when the denominator is decreasing by 20 and the numerator is increasing by 20, that fraction is going to be 5 over 22. And just to show that this is going to work, this sum is 27, and this is equal to 25 over 2. And again, sum is 27. And you'll find that if we continue this table, the next fraction is going to be 10 over 44, but 10 over 44 is just equal to 5 over 22. So we'll find that the only fraction where the denominator is a multiple of 11 that'll work for r is going to be r equal to 5 over 22. So therefore, those are all the cases we're looking at when the denominator is a multiple of 11 and when the denominator is a multiple of 5. So all the elements of S are going to be, it's just 5 over 22 and 2 over 25. So the sum of all the elements of S, which will help us find what we're trying to find, is going to be 5 over 22 plus 2 over 25. That sum is 169 over 550. So this is P, this is Q. And these two numbers are relatively prime. So P plus Q then is 169 plus 550, which is 719, which is our answer.